Hello, we're going to present the problem number 3, which is function of x equals to 1 over x squared minus 1. First we need to find the restrictions and domain of it. So we can make this function x minus 1 times x plus 1. Then x we equal it to 0 and we got that x equals to 1 and x equals to minus 1. So we can see that the domain is x equals to all the real numbers except 1 and minus 1. For the x and y intercepts, first we are going to find the x-intercept. So all the whole function is going to be equalized to 0 as such. Then we isolate x and we get that x equals to 1, so the x-intercept does not exist. And for y, we change all the x's for 0 and we got 0 over 1 over minus 1, which is minus 1, so the y-intercept equals to 0, minus 1. For part C, we need to find the symmetry. So the whole function is going to be f of minus x equals to 1 over minus x squared minus 1. So then the minus x multiplies it by itself, giving us x squared minus 1. So f minus x equals to fx, making the whole function an even.
So first we have to get the first derivative of our function, and as it is a fraction, we have to use quotient. So we eliminate this part and we continue with this, which is f of x times the prime of g of x, and g of x to the square, which will give us that the first derivative of our function is minus 2x over x squared minus 1 to square. So now we're going to calculate our critical value by having our function equals to 0. So we divide our function over minus 2, so we can simplify minus 2. We pass this part to the other side, 0 times this is 0, so x is equal to 0. So now we're going to calculate our critical point by substituting the critical value in our original function. So f of 0 is equal to 1 over 0 squared minus 1, which will give us 1 over minus 1, which is minus 1. So our critical point is going to be 0, minus 1. So this is our t-chart. These are the intervals of the graph. These are the values that we chose, which are between the intervals. And we substitute this in our prime derivative, our first derivative. So in the first value, we got a positive result, so it's going to be a positive graph. In our second value, it's a negative result, so then the graph is negative. And in the third, it's also negative, so our conclusion is that the last graph is also negative. Now, after we have our critical point, we have to choose a number that is going to be bigger and smaller. So we choose minus 1 and 1, and we substitute it in the first derivative, which f prime of minus 1 is going to be 2 over 0, and f prime of 1 is going to be minus 2, 0. And since it is positive on the right and negative on the left, then our critical point is going to be our maximum.
The result we got from the second derivative, we're going to equal it to 0 to get the concavity test. Now, to know the inflection point, we're going to leave x alone. Since this is an imaginary number, there is no inflection point. And since there is no inflection point, there's no concavity test.